Unit 3. Flood Hazards and Flood Maps. Understanding different types of flooding. Flooding occurs in many different ways, and understanding these differences is crucial for effective floodplain management. Riverine flooding, also called fluvial flooding, occurs when rivers and streams overflow their banks. This is the most common type of flooding addressed by NFIP, and typically develops over hours or days as rainfall accumulates in a watershed. Riverine flooding can be further classified into several subtypes. Flash flooding occurs when intense rainfall causes rapid rises in water levels, typically within 6 hours of the precipitating event. Flash floods are particularly dangerous because they develop quickly and often with little warning. They are common in areas with steep terrain, urban areas with lots of impervious surfaces, and regions with clay soils that do not absorb water quickly. Coastal flooding results from storm surge, wind-driven waves, or astronomical high tides. Storm surge is the abnormal rise in sea level during a storm, caused primarily by wind pushing water towards shore. Wave action adds additional height and energy to coastal floods, creating particularly destructive conditions. Coastal flooding can occur rapidly during storms and may be accompanied by erosion that permanently alters shorelines. Urban flooding occurs when stormwater systems become overwhelmed by rainfall that exceeds their design capacity. This type of flooding is becoming more common as development increases the amount of impervious surfaces in watersheds, causing more water to run off instead of soaking into the ground. Urban flooding can happen even in areas not traditionally considered flood-prone. Shallow flooding occurs in areas where water accumulates to depths of 1 to 3 feet, typically with low velocities. This type of flooding is common in flat areas where drainage is poor. While shallow flooding may seem less threatening than deeper floods, it can still cause significant damage to buildings and vehicles. Ice jam flooding occurs when ice blocks river channels, causing water to back up behind the jam. When the jam eventually breaks, it can release a sudden surge of water downstream. Ice jam flooding is most common in northern climates during spring thaw or during winter warm spells. The Science of Flood Insurance Studies, Flood Insurance Studies, or FIS reports, are comprehensive technical documents that analyze flood hazards in a community. These studies use sophisticated hydrologic and hydraulic modeling to determine how much water will flow during floods of different magnitudes and where that water will go. The hydrologic analysis determines how much water will flow in streams during floods of various frequencies. This analysis considers factors like watershed size, soil types, land use, precipitation patterns, and existing flood control structures. The result is a set of discharge values for different frequency floods, such as the 10-year, 50-year, 100-year, and 500-year floods. The hydraulic analysis determines where floodwater will go and how deep it will be. This analysis uses computer models to simulate water flow through the landscape, taking into account channel geometry, floodplain topography, bridge and culvert openings, and other factors that affect water movement. The result is water surface elevations at different locations for different frequency floods. Modern flood studies use sophisticated computer models like HEC-R, which can simulate complex flow patterns including backwater effects, split flows, and the influence of structures like bridges and levees. These models require detailed topographic data, which is increasingly obtained using light detection and ranging, or LIDAR, technology that can measure ground elevations to within inches. The 100-year flood, or base flood, is the regulatory standard for NFIP, but studies also analyze other frequency floods. The 500-year flood is used for critical facilities like hospitals and emergency operations centers. The 10-year and 50-year floods help show the range of flood risks and are used in some local regulations. Reading and interpreting FIRM's flood insurance rate maps, or FIRMs, are the official maps that show flood risk information for communities. Learning to read these maps accurately is essential for anyone involved in floodplain management. FIRMs show special flood hazard areas, base flood elevations, floodway boundaries, and other critical information needed for regulatory decisions. The most important elements on a FIRM are the flood zone designations. Zone A areas are special flood hazard areas where detailed hydraulic analyses have not been performed, so no base flood elevations are shown. Zone AE areas are special flood hazard areas with base flood elevations determined through detailed studies. Zone AH areas have shallow flooding with standing water depths of 1 to 3 feet and base flood elevations shown. Zone AO areas also have shallow flooding, but instead of showing base flood elevations, these zones show flood depths. Zone VIVE and VE are coastal high hazard areas subject to high velocity wave action. These areas have the most stringent construction requirements because of the extreme forces involved in coastal flooding. Zone X areas are outside the special flood hazard area and have less than 1% annual chance of flooding. However, this does not mean these areas never flood. Zone X shaded areas have between 0.2 and 1% annual chance of flooding, while Zone X unshaded areas have less than 0.2% annual chance of flooding. Base flood elevations on FIRMs are shown in several ways. In Zone AE areas, BFEs are shown along the watercourse at regular intervals, typically every 500 feet. Cross-section lines on the map show where detailed hydraulic analyses were performed, and these cross-sections are referenced to detailed profiles in the flood insurance study. Floodway boundaries are shown as dashed lines within Zone AE areas. The floodway includes the channel and adjacent areas needed to carry floodwater without increasing upstream flood elevations by more than 1 foot. Development restrictions are most severe in the floodway. Panel numbers and effective dates are critical pieces of information on every FIRM. The panel number identifies the specific map sheet, which is important when ordering elevation certificates or researching property locations. The effective date shows when the map became official for regulatory and insurance purposes. Digital flood maps and modern technology, digital flood insurance rate maps or DFIRMs, are gradually replacing traditional paper maps. DFIRMs provide the same information as paper FIRMs, but in a digital format that allows for more precise measurements and easier updates. The digital format also enables integration with Geographic Information Systems, or GIS, for more sophisticated analysis. FEMA's Map Service Center provides online access to effective FIRMs and related products. Users can search by address, view current effective maps, and download digital data. The system also provides access to preliminary maps for areas undergoing map updates. LIDAR technology has revolutionized flood mapping by providing extremely accurate elevation data. LIDAR uses laser pulses to measure distances to the ground, creating detailed elevation models that show the landscape in 3 dimensions. This technology allows for much more accurate flood modeling and mapping than was possible with traditional surveying methods. The National Flood Hazard Layer, or NFHL, is a digital database that contains current flood hazard information for the entire United States. The NFHL is updated continuously as new maps become effective, providing the most current flood hazard information available. RISC-MAP is FEMA's current approach to flood hazard mapping, focusing not just on regulatory products but also on risk assessment and communication tools. RISC-MAP products include depth grids, showing how deep floodwater will be in different areas, flood risk databases that can be used for detailed analysis, and changes since last FIRM datasets that highlight areas where flood risks have changed. Map updates and revisions. Flood maps are not static documents, but are updated periodically as new information becomes available or as physical conditions change. There are several types of map updates, each serving different purposes and following different procedures. Physical map revisions, or PMRs, are comprehensive updates that typically involve new flood studies and completely new maps for a community. These updates might be triggered by significant development in a watershed, new scientific techniques that provide better analysis, or recognition that existing maps are significantly outdated. Letters of Map Revision, or LOMRs, are official revisions to effective FIRMs. LOMRs are typically issued when communities or developers submit technical data showing that flood risks have changed due to natural or human-caused changes in the floodplain. Common reasons for LOMRs include channel improvements, bridge or culvert installations, and placement of fill that affects flood flow patterns. Letters of Map Amendment, or LOMAs, remove properties from special flood hazard areas when it is shown that the properties are on naturally high ground and were inadvertently included in the SFHA. LOMAs require detailed topographic surveys showing that the lowest adjacent grade of the building is at or above the base flood elevation. Conditional letters of map revision, or CLOMRs, provide preliminary approval for projects that will affect flood hazards. CLOMRs are issued before construction begins and confirm that a project, if built as proposed, will result in a LOMR. This gives developers and communities confidence to proceed with projects that will modify flood risks. The map revision process can be complex and time-consuming. It requires detailed technical analysis, often including new hydraulic modeling, and must meet FEMA's standards for accuracy and methodology. The process also includes public notification and opportunity for comment, since map changes can affect insurance rates and development opportunities for many properties.